extremely popular because of its theoretical properties and practical nature as well. Support vector machines. It is a linear classifier. Again, it draws a linear boundary between the classes. I will set up everything with respect to the binary classification, and then you know how to extend it to multi-class. We always know how to extend a binary classifier to multi-class classifier. Yes?
Yes.
So far we have studied two linear classifiers. One is linear regression, and then we make the regression linear classifier. And then the other one is logistic regression. Both have merits and demerits. But we saw theoretically logistic regression is robust to outliers or less sensitive to outliers. It is sensitive to outliers, but as compared to least squared or linear regression, it is less sensitive to outliers. Today we will study SVM, which is theoretically better than even logistic regression, theoretically, which means for your data set, you cannot claim that SVM will work the best. Make sense? Yes, if you try out different classifiers to several data sets, SVM tend to work fine. That's why it's more stronger. Make sense? So let's study it. ये क्रॉस बंद कर सकते हैं
सुकून आ गया
change everything. Let's say we have two classes. Let's say this is the data set from two classes. Let's say this. Okay. And let's say we want a linear separator or linear decision boundary between it. We can find out the linear decision boundary using linear regression. We can find out the linear decision boundary using logistic regression or any other linear classifier. Okay. Let's say this is a linear decision boundary given by some algorithm. Let's say A1. The algorithm is A1. It might be a linear regression algorithm. It might be a logistic regression algorithm, and so on. This is algorithm 1 that gives you this decision boundary. Make sense? I am assuming feature space is two-dimensional, so I'm plotting it here. Okay. Let's say another decision boundary given by another algorithm that we call it A2 is this. Okay, that's the decision boundary. Let's say we have another algorithm which is A3, and that gives us the following decision boundary. Let me draw it in solid. I should use another colored marker, but yes, color marker.
Okay.
Oh, yeah. This is algorithm 3. Okay. By visualization, intuitively, which boundary will you prefer? If somebody come up with, you give a training data, this is the training data. You give the training data to 3 different companies and ask them to come up with a linear classifier. And one company or one client or algorithm give this decision boundary, another one give this decision boundary, and another one give this decision boundary. Visually, which decision boundary is better? Visually. A3? Consistently?
Yes.
Anybody in the favor of A1 or A2?
हम ऐसे तो दादा लगा ही नहीं सकते, डिपेंड करता है कि हमारी एप्लीकेशन क्या थी। अगर कोई ऐसी एप्लीकेशन
Application classification.
अगर हमारी क्लासिफिकेशन हमें उन प्रोजेक्टों के द्वारा करनी थी जिनमें हमारे पास क्लास ए है, उसमें हम कुछ भी हल्का सा भी नॉइज बर्दाश्त नहीं कर सकते, उसकी बाउंड्री बहुत स्ट्रिक्ट रखनी थी, हमें बहुत शार्प रखनी थी, तो माइट बी A2, तो हम ये तरीका सकते हैं विदाउट नोइंग क्या।
So the assumption about the data is same for all 3 algorithms. So this is the training data. All the assumptions are fixed for A1, A2, and A3. Now these 3 boundaries come. Which one will you pick, regardless of the data the assumptions can? That's the training data. These are the 3 classifiers. You are to choose one of them. which one will you prefer? Given this information, that's it. A3. And now the natural question is why? Yes.
तो इसका दोनों क्लासेस से जो इस क्लास का डिफरेंस है वो दोनों का डिफरेंस है।
And that gives what benefits?
अगर
So he is saying the A3, which is the red line, it actually separates the two classes in a good way. It has some margin, so to speak. It has some margin. So let's say the two classes. If this inside is the boundary, then this is still the margin it has. So separating margin or something like that. The others have less margin or even no margin. So uska fayda kya hai? If the red line is separating the two classes by keeping a particular margin, ठीक है? What is the benefit?
अगर कहीं नॉइस थोड़ी ज़्यादा कम भी होती है तो क्लासिफायर स्टेबल रहेगा।
Yes. If noise ज़्यादा कम होती है या मज़ीद data points आते हैं, see, in the case of A2, you are very close to the points of class 1, and it can happen that when new points, जब नए points आए, a new point just arrive here, and this classifier is so strict that it will misclassify it. Make sense?
Yes.
By keeping a margin, you are safe with respect to that kind of error.
Yes.
Make sense? Yes, no?
Yes.
So that's a natural choice, intuitive choice. If you have multiple decision boundaries, you want to pick one of them, the intuitive choice is pick one that maximizes the margin, that have safety margin both sides, the max. Yes, no?
Yes.
Now let us define what do we mean by margin. Let's mathematically define margin, the term margin. सही है जी?
सही।
Margin. मैं रेड में show you. Margin की spelling नहीं है? G आता है? J तो नहीं आता है? And में E आता है? Okay, margin. It is the distance of the closest point to the boundary. So margin of a boundary, or let me call this boundary as line or what? So this boundary is our decision boundary, or the separator or whatever. So margin is the distance of the closest point to the boundary. So, and the closest point is in either way. I mean, first of all, it is a separator. It is a boundary. It is a separator. It separates class 1 from class 2. Now, that separator, which point is closest to that separator with respect to the distance? Which point is closest to that? So the distance of the closest point to the boundary, that distance is defined as margin. And that margin can be from class 1 and that margin can be from class 2. I mean, ज़रूरी नहीं है कि वो closest point class 1 का होना चाहिए, 2 का होना चाहिए. Whichever point that is closest to it, the boundary. Number 1, it is separated, so it is inside the two classes. Now, inside the two classes, which one is the closest? This particular point, this point is closest to the boundary. So what is the distance of the closest point from the boundary? That is margin that boundary has. Make sense? Yes, no?
Yes.
Question.
सर एक क्लास का डाटा दूसरी क्लास के डाटा में इंक्लूड हो सकता है?
अभी तक हम ये assume कर रहे हैं कि the data is linearly separable. इसके बाद हम इसको relax करेंगे. So that's a good question. The question is, what if there is no line that separates the data? अगर data है ही ऐसा, तो कोई दुनिया की ऐसी line नहीं है जो उसको separate कर सके. There is no linear decision boundary, which technically is called the data is not linearly separable. We will handle that case. We will start from the assumption that the data indeed is linearly separable, and then we will relax this condition, and the formulation will not change. बहुत ज़्यादा change होगी नहीं. Formulation में हम डिजाइन करेंगे linearly separable case के लिए. That will not change much, and we will relax this condition that the data is linearly separable, and will be having general classifier. So that's a good question. Right now, we are assuming data is linearly separable, so there exist one or more linear boundaries that separate the data. Yes? Okay, this is the definition of the margin. Is that okay with everyone? Our goal, or the goal for the SVM, support vector machines. Okay, मैं ये पता नहीं क्यों लिख रहा हूँ.
हेडिंग है
जी?
हेडिंग
ये मतलब ये भी है.
पता नहीं ये बड़ी हेडिंग है
Big idea, small idea. Find a boundary. There might be multiple boundaries. Find a boundary having max margin. That's how. So the goal is find out a boundary that has maximum margin. So for example, for this particular boundary, the margin is very little because this is the point closest to it, so that's the margin it has. Yes? For this boundary, the margin is again very little, this is the closest point. For this boundary head, this is the margin. Oh, sorry, this is the margin. That's the closest point.
Yes, sir.
Make sense?
Yes.
Yes? Yes. If our goal is to find out, so you can have several boundaries. You want to pick the one that has maximum margin. That's the goal.
No.
And that goal is intuitively explained there. The maximum margin classifier tends less towards the errors because it has a safety margin on both sides. Margin is for both the classes. So that's a good question. Margin ऊपर वाली क्लास से ले रहे हैं नीचे वाली क्लास से. अगर किसी एक क्लास के वो करीब है और दूसरी से दूर है, तो I can always shift the boundary to increase the margin. So ये basically दोनों के लिहाज से होगा. अगर देखें ना एक पॉइंट करीब है, ठीक है, और दूसरा पॉइंट दूर है, तो मैं बाउंड्री को थोड़ा सा चेंज करके तो इसको भी मजीद दूर कर दूंगा. सो ये जो मार्जिन आएगा ये डेफिनेट इधर भी एटलीस्ट एक पॉइंट होगा, इधर भी एटलीस्ट एक पॉइंट होगा जो बाउंड्री को शिफ्ट नहीं होने देगा, एंड देन द बाउंड्री इज लॉक्ड, अदरवाइज इट विल फ्लोट. सो ये दोनों साइड से कंट्रोल होगा. सो ये जो बाउंड्री का मार्जिन कंट्रोल करने वाले पॉइंट्स हैं, सो टू स्पीक क्लोजेस्ट पॉइंट से दोनों साइड पे लाई करेंगे. मेक सेंस?
दोनों से इक्वल होंगे वरना हमेशा मूव कर सकता हूँ.
इक्वल दोनों साइड से इक्वल होंगे. और ये एक से ज़्यादा पॉइंट्स भी हो सकते हैं. जरूरी नहीं कि सिर्फ एक क्लास का एक पॉइंट हो, दूसरी का एक पॉइंट हो. You can have multiple points for one class having the same distance, and the multiple points from the second class having the same distance. And one of those, I mean all of those, they are defining the margin. अगर किसी एक साइड पे मार्जिन अचीवेबल हुआ तो हम उस साइड पे शिफ्ट कर जाएंगे. So they will control. Yes. So the margin is equal to both of the classes, towards both of the classes. Yes. Is that okay? Yes. No.
Yes, sir.
This is. मैं यहाँ थोड़ा सा आपको इसका रिलेशनशिप बताता चलूँ लॉजिस्टिक रिग्रेशन से थोड़ा सा. Then I will tell you the superiority of SVM over logistic regression in general settings later, maybe in today's class or in the next class. But right now, I'm going to tell you that this kind of idea is not very new. Actually, logistic regression is also doing the same thing in a disguised way. Let's see how. If this is the closest point, you really want your W transpose X to be very greater than 0. I mean, it should be a very big positive number. Make sense? That's why you will be increasing the margin most. Make sense? If so, if xi, if yi is equal to 1, you need this thing to be very, very large. And you need this thing particular for the point that is closest to it. Make sense? मेरी बात समझ आई? आपने डिस्टेंस इंक्रीज करना है ना बाउंड्री से, तो W ट्रांसपोज X जितना बड़ा नंबर होगा उतना हम दूर होंगे बाउंड्री से। यही हम पहले भी यही करते हैं लॉजिस्टिक रिलेशन में भी, सही है? लेकिन अब आप ये कर रहे हैं फॉर द पॉइंट व्हिच इज क्लोजेस्ट टू द बाउंड्री। You need the closest point to be very far away, as maximum as possible. Yes? So let me call it if this. Or same, if the closest point has this label, then it should be very far away on the other side. Make sense? This is happening only for the points that are controlling the boundary. In SVM setting. SVM says, I mean, find out the boundary so that the closest point to it is far away. Obviously, if the closest point is far away, the points that are not closest to it are very far away.
Yeah.
So you are achieving what you want to achieve. Yes? Now, think in the terms of logistic regression, what we have done. In logistic regression, remember, the sigmoid of W transpose X is actually the probability of y equals to 1 given X. Yes? Or let me not write the given thing, just to, this is the probability that y is equal to 1. And this probability, I mean, you are more confident if this number is bigger and bigger. Yes or no?
Yes.
So in that case also, you need this thing. Make sense?
Yes, sir.
To be sure that it is of class 1 and to be sure that it is of class 0, you need this. Make sense? So the same thing you have done in logistic regression as well. But in logistic regression, you say, okay, find out the separator so that all the points of one class, they are far away from the boundary, and all the points of the other class, they are far away on the other side from the boundary. And this includes also, if all the points has to stay away, then the point that is closest to the boundary has to stay away again. मेरी बात समझ में आई?
आखिरी बात समझ में आई।
दोबारा से देखिए, अगर मैं प्रॉब्लम सेटअप इस तरह से करूँ, find out the boundary so that all the points of class 1, they should be far away from the boundary. Make sense? Then it includes as a sub-case, as a case, that the closest point also has to stay away from the boundary. Because all the points, they have to stay away from the boundary.
Yes, sir.
Yes, no?
Yes.
So logistic regression में भी यही काम आप कर चुके हैं, यानी अगर आप कहेंगे अब आप एक ऐसा क्लासीफायर लेके आ रहे हैं जो बड़ा मार्जिन को इंक्रीज कर देगा और क्लास 1 को बड़ी दूर फेंकेगा, क्लास 2 को बड़ी दूर फेंकेगा, things will like that, वो happen हो जाएंगी बड़ी, यानी तो that is there in logistic regression as well.
तो फिर इसका क्या कमाल?
Yes, इसका क्या कमाल? The कमाल of SVM is sparsity. अभी हम थोड़ी देर आगे जाएंगे तो हम देखेंगे SVM में जब आप इंतहाई हाई डायमेंशनल फीचर स्पेस में जाएंगे या आप बहुत हाई डिग्री पॉलीनोमियल फिट करेंगे, the overfitting will not be there in a principled way. Make sense? That's the edge of SVM over logistic regression. Logistic regression also achieves the margin. It also does the same thing, and for one class stay away, from the other class stay away. But the way SVM problem setup is there, the way it's set, the SVM model, जैसे हम mathematics इसके लिखेंगे, the way it imposes the problem actually includes inherently that if you are going to fit a very high degree polynomial or you are applying a kernel, that kernel puts everything to a very high dimensional space, even a infinite dimensional space, overfitting will not be there. And overfitting will not be there, it is, I mean, justified in a mathematical way, not in just hand-waving arguments and stuff like that. Make sense? So that is the edge of SVM over logistic regression. मेरी बात समझ में आई है नहीं? क्लियर है?
Yes.
So अगर आप ये कहेंगे SVM जो है वो लॉजिस्टिक रिग्रेशन से इसलिए अच्छा है कि मार्जिन बहुत ज़्यादा अचीव कर लेता है, लॉजिस्टिक नहीं करता, लॉजिस्टिक भी करता है। लॉजिस्टिक में आप ये कर रहे हैं, आप प्रोबेबिलिटी को 1 पे लेके जाने के लिए पॉइंट्स को दूर करते हैं और प्रोबेबिलिटी को 0 पे लेके जाने के लिए दूसरे पॉइंट्स को दूर करते हैं। So some way or the other, even if you do not define explicitly margin there, margin is being achieved there. Make sense? It is the flexibility of the model that even if you want to, I mean, fit a very complicated model in SVM, popularly using by kernel, even if you want to use a Gaussian kernel, आप बाद में देखेंगे, तो actually you are fitting your data, which is actually infinite dimensional, and still you are justifying that there is no overfitting. इससे पहले आप ये करते थे कि अच्छा हम हाई डायमेंशंस में जा रहे हैं, तो regularizer will take care of everything. Now you will see that the parameters are actually small, the solution is actually sparse. We will see that, and that is the basic difference of logistic regression and SVM. And this particular difference of SVM, I mean, it generalizes very well. Even if you fit very high degree polynomials in the SVM setup, it has generalization error much better theoretically as compared to other models because it will not overfit. Make sense? And that is the key popularity of this. The other popularity is implementing the kernelized version of SVM is straightforward. It's अभी हम derivation देखेंगे थोड़ी देर बाद. इसकी derivation में incorporating the kernel inside is not a big deal. It's straightforward. Just, I mean, you have not to do anything extra. You write the SVM code which is non-kernelized, and you write the SVM code which is kernelized, close to identical. Not a big deal. Incorporating kernel is not a big deal, and kernel is justified here. Make sense?
Yes, sir.
So you should be very clear about this. अगर आपसे पूछे कि यार SVM जो मार्जिन अचीव करता है तो क्या इस वजह से ये बेहतर है? Yes, but this is not the only reason. Logistic regression also achieves the margin. The reason is generalization. Make sense? Yes, no?
Yes. कर्नल सिर्फ एक फिल्टर ही होता है।
Sorry?
कर्नल सिर्फ फिल्टर ही होता है इसमें।
No. I don't know. इससे पहले फिर ये देखना पड़ेगा what do we mean by filter. Filter को पहले define करना पड़ेगा. तो फिर शायद ये फिर देखो. So what do we mean by filter? इसको देखना पड़ेगा. अगर आप mathematically बताएंगे कि this is the definition of the filter, then we have to look into it whether kernel is a filter or not. जो हम computer vision में filters पढ़ते हैं, जो normally average out कर रहे होते हैं चीज़ों को this and that, I don't think कि ये उससे कोई resemblance रखता है.
वो जो टारगेट पे जाता है एज डिटेक्शन करनी होती है।
Yes.
तो उसमें जो 3x3
जो masks होते हैं.
हाँ, उसकी मास्क को कर्नल ही कहते हैं।
Yes. I don't see कि ये उसके साथ resemblance रखता है. Kernel की फर्क definitions भी हैं. I'm not sure कि ये kernel exactly वही kernel है या नहीं है, लेकिन I guess कि वो जो kernels हम computer vision में पढ़ चुके हुए हैं, the masks और the matrices जिनके साथ हम convolve करते हैं अपनी images को, they have nothing to do with this.
Yes.
Make sense?
Yes, sir.
Okay, so that's our goal. If the problem setup is okay, but till now we are moving towards this math. If the intuition is clear, intuition is we want to fit a boundary so that the closest point is not that close to the boundary. And if it is close to the boundary and there is another boundary कि उसके closest point है वो उससे दूर है, so we want to find out a boundary that has maximum margin. और हर बाउंड्री का मार्जिन डिफाइन करने वाला क्लोजेस्ट पॉइंट उस बाउंड्री का अपना होगा. ये नहीं कि जो क्लोजेस्ट पॉइंट है वो हमने फिक्स किए हैं. सो प्रॉब्लम इतनी सिंपल नहीं है. अगर वो पॉइंट्स आपने फिक्स किए हैं, these are the closest points, these are the points called the closest points, then the problem is simple. I think you come up with a new boundary, another boundary, और उस बाउंड्री का कोई क्लोजेस्ट पॉइंट है जिसका कोई मार्जिन है उस बाउंड्री से डिफाइन करेगा. सही है? So we have no points that are fixed, that are closest, not closest, stuff like that. Yes, no?
Yes.
So this is again our goal, but the goal is for the closest points. Yes?
Yes, sir.
Yes, sir.
This was our goal for for all the points, and the same setup was called logistic regressions. Clear? Yes, no?
थ्योरेटिकली तो लॉजिस्टिक रिग्रेशन बेहतर हो गया ना, क्योंकि इसमें तो हम सिर्फ क्लोजेस्ट पॉइंट के लिए ही बात कर रहे हैं।
It is difficult to say in that sense क्योंकि जब आप कहते हैं कि find out the boundary that has that the closest point to it are far away, then you are implicitly saying that all the points are far away. और जब आप कहते हैं find out a boundary that all the points are far away, then you are implicitly saying that the closest points are also far away. So I don't see there is the one thing that is that is enclosing the other and more general. I guess they are kind of equivalent statements. Make sense? Okay, so one modification that I am going to use now, अब तक हम ये यूज करते हैं कि W is this, W0, W1, WD, where D is the dimension of the data, or X extended is 1, X1, XD. This is what we used till now. Clear? Actually ज़्यादा बेहतर होता कि हम W को भी W extended कहते तब, कि extended पे काम करने वाला है। ये मैं ऐसा क्यों कह अब तक हम W जिसको कहते हैं, I guess कि उसको start में हमें W extended कहना चाहिए, and the reason is the following. If I define W like this, W1, W2, WB, and X as then this thing transpose X हमने कैपिटल X मैट्रिक्स के लिए कहा था, so let me call it X. W transpose X is equivalent to W transpose X plus W naught. That's all. I mean no difference. Just ये हम ऑलरेडी देखते रहे, हम इस वे में ऑलरेडी इंप्लीमेंट करते रहे, ठीक है? और ये इंप्लीमेंटेशन एग्जैक्टली यही है। इसकी कोई रीजन है इस फॉर्म में लिखने की, लेकिन ये these two forms are equivalent. I mean आप x को एक्सटेंड कर दें मान से और w नॉट यहाँ पे इंक्लूड कर दें, then this is a simple dot product. हमने लीनियर रिग्रेशन में देखा था बहुत वेक्टराइजेशन करनी है वगैरह वगैरह. Yes? Now we are breaking the pieces again. We are breaking in these things into simple terms. I'm calling these things, this thing as W, this thing as X, and now WX plus W naught is what this was. ऐसा ही? Yes, no? Yes. It is just a matter of notation that if you see in several books or literature, this W naught is written as B. It is written as B. And people also name it as bias. Make sense? It is written as B. If you are comfortable with W naught, write W naught. Because from the very beginning till now, we wrote this as W naught. It's a parameter. So still it is a parameter because but the technical letter people mostly use for it is B. And technically people call it bias. Make sense? So if you are comfortable with W naught, go with the W naught, but I will write B so that if you do not confuse this W naught with B, W naught कोई और चीज़ है, this B is something else.
Why specifically these terms are bias?
Okay, so इसको erase कर दूँ?
Yes, sir.
This B is let's say you want to find out some linear boundary from this data. This is the data, and let's say you want to find out some linear boundary, okay? And this is, let's say, the equation, W transpose X plus B, that's the equation, okay? That's the equation. W transpose X plus B equals to 0, that's the equation. So that is the boundary, that is some boundary, W transpose X plus B equals to 0. That is some line. Make sense?
Yes, sir.
Okay, any point that lie on this line makes 0, any point that lie above, one side of this line, this number will be positive, other side of this line will be negative. If B is not there, your equation is W transpose X equal to 0. Then you are not allowing your separating boundary to leave the origin. Okay? For example, if you have 2x plus 3y plus 4 is equal to 0, in this particular case, this is a line that is not passing through origin.
Yeah.
This is not passing through origin. And this is not passing through origin because of this number. Because of this number. If this is not there, if this number is not there, and in your model you do not allow a constant addition. If you do not allow that, then you are forcing your boundary. So come up with a separating boundary, but that boundary has to pass through origin. Make sense? If this constraint is there, in this particular case, this is the best separator, I guess. If you force the condition by not allowing the B, by not allowing the additive constant here, if you do not allow the additive constant, then you are forcing, okay, always pass through origin, always pass through origin. And in that case, you may come up with this kind of boundary, and that is the best, which is not bad. Make sense? So this term, additive constant here, this, it has an impact. It allows you to stay anywhere in a space, and it just shifts it does not change the orientation of the line, orientation of the plane or stuff like that. Whatever plane orientation is defined by W, the direction of the line or the plane, whatever. Yes. And this B works as a shifting of it. Make sense? Now the second question is, why it really is called bias? Why it really is called bias? I have no answer to it. Because the bias has two different meanings. One is this bias, which is the additive constant in the linear equation, the additive constant, that's called bias. Another term is bias is used as another term in machine learning, bias and variance. If bias is high, that means your model is simple. If bias is low, or the variance is high, that means your model is complicated. So if you say, so I'm going to speak some equivalent kind of statements. Statement number 1. I have fitted a very simple model in my data. That's my statement. Okay? I fitted a very simple model. Fitted, okay, doesn't matter. Okay. I have fitted a very simple model in my data. That's one statement. The equivalent statement is, the model I have fitted in my data has very low bias. Make sense? The other statement, I have fitted a very complicated model in my data. The equivalent statement is, the data, when last time low bias, high bias, that was high bias, I'm sorry, high bias. I have fitted very complicated model in my data. The equivalent statement is, I have fitted a model in my data that has low bias or high variance. Bias and variance, ठीक है? और वहाँ पे bias और variance को वो explain करते हैं किसी तरीके से. I can explain that right now, but यहाँ पे ये जो B है, ये इसको bias क्यों कहते हैं? I mean, why it is called bias? Why it is not called a fan or something like that? I have no intuition of it.
इधर में variance वाली क्या बात है?
So bias and variance, that's a trade-off. अगर bias ज़्यादा होगा, variance कम होगा. ये मैं थोड़ा सा आपको बता दूं, मॉडल जितना फ्लेक्सिबल होगा ना, उतनी उसमें वेरिएशन ज़्यादा पॉसिबल है, उतनी ज़्यादा वो वेरिएशन को कैप्चर कर सकता है जितना फ्लेक्सिबल मॉडल होगा. सो हाईली फ्लेक्सिबल मॉडल को कहा जाता है कि इट हैज़ हाई वेरिएंस. मेक सेंस? और जब वेरिएंस हाई होगा ना तो बायस कम होगी. जब बायस हाई, बायस मींस, सो हाई वेरिएंस मींस लो बायस. बायस किसे कहते हैं? मैं ये थोड़ी सी चीजें हम थोड़ी सी और एक्सप्लेन करने की कोशिश कर रहा हूँ जस्ट इन 2 or 3 more minutes. Bias means you are not looking in the data and you are biased towards fitting model. So for example, data is screaming, I mean, please try 3D polynomial, please, and you are biased towards. You are not looking at the data, you are not expecting the data, and you are, oh no, this 1D polynomial. So you are highly biased towards that, and you are not allowing the variability in the model. So high bias, low variance. Make sense? High variance, low variance. So variance high over, you are respecting the data and you are not biasing it. Make sense? Yes, no? Yes. Okay. So your question, why this is called bias, I don't know. But this is not the bias that I have explained just a few minutes before. This is not the bias variance trade-off वाली bias. This is not. Clear? मैं तो इसको offset कहता हूँ. And
It makes sense.
works. Is that okay? But ये याद रखें, ये चीजें जो थ्योरी में इंट्रोड्यूस हुई होती हैं, they are not nonsense. इसकी जरूर कोई ना कोई explanation होगी कि why it is called bias and why it should be called bias. So there must be some very intuitive explanation, maybe mathematical and stuff like that. So if you are very curious, you should go for that and learn about it. Make sense? I didn't find it important to see why it is called bias, as long as I can use it effectively. Make sense? So, I mean, this will not be completely nonsense case. So, this is a bias study and now it is moving on. There may be some intuitive bit in there. Is that okay? So, from now onwards, I will write, जो मैं traditionally write किया जाता था, उसकी जगह पे मैं ये लिखा करूँगा, W transpose XP, and W should not be confused with this complete W. It is W without W naught, which we now are calling as P. Make sense? Yes. Yes. No. Yes.
Makes sense.
Yes.